Okay, I forgot to click a button here. Too many buttons to click. I came up one short. So the corresponding higher resolution graph isn't going to be the same length of this one, and you won't get to see me construct everything. But the idea is fairly clear. Okay, so we want to construct the graph of the cosecant function based, and we want a construction. Now we can't directly construct, well, we could, I guess. It'd be a multi-step process. But probably the most efficient way to see the construction is assume, okay, we first constructed a sine graph, and we know how to do that. So we've got a sine graph all ready to be used. Okay, now the cosecant, which is abbreviated by CSC, the cosecant function is the reciprocal of the sine function. And by this I simply mean that the value of the cosecant at a given point is the reciprocal of the value of the sine at that point. Okay, well, how do we do a reciprocal? Well, I've actually done it here. Given a segment of length x, I claim that we can construct a segment of length 1 over x using compass and straight edge. And I've actually used the compass. Okay, I've got a segment here now. This is a segment of length x. And, okay, that segment is this long. Now down here I've constructed a right triangle, or what's supposed to be a right triangle. I didn't do all the construction, but obviously I could have. Okay, and the hypotenuse here is x. Now, in order to do the reciprocal, we have to know how big 1 is. We're constructing an unlabeled graph, so it doesn't matter how big we decide to make 1. So I decided to make 1 this big. Okay, so that's how big 1 is. Now, you could construct this using any length for 1. Could be greater than the length of x, could be less than the length of x. Any length at all. But this is a fairly convenient length to use. And what I did was I took this length and I sketched a side here. So that now I have a right triangle with a side x and a side 1. Side x here, side 1 here. Now I want to get the reciprocal of x. Well, it turns out that I can do that. Okay, I construct another triangle within this one where the unit length, 1, which is the same as this, so I mark that length here. Right here I have unit length 1, and that'll be my hypotenuse. And I've got a question mark there. I'm not sure you can see if that's a question mark, but it is. I've got a question mark there indicating I'm not sure what the length of this side is, but I'm hoping it's going to turn out to be 1 over x. And it turns out that it did. I got it right. Okay? Had I not gotten it right, I would have had a start on constructing it, and I probably could have modified my construction. So this idea I knew was going to be fruitful, so I wrote it down the way I thought it was going to be, but I hadn't worked it out. And it actually worked out the way I thought it would. Okay, well, I'll observe that this triangle, if everything is at right angles and so forth, is geometrically similar to the bigger triangle, which means that what? It means that the ratio of this to this, which is 1 over x, which is the reciprocal, will be the same as the ratio of this question mark side to 1. So that 1 over x equals question mark over 1. Well, if that's the case, and it has to be if these triangles are similar, unless I'm very confused right now, it's always possible, so check me out. Question mark over 1, whatever question mark represents, is just going to be question mark. So that question mark equals 1 over x. You can also see this, multiply both sides by 1. You still get question mark equals 1 over x. Okay, so that this short side here, construct a segment of that length. I think I made it a little bit long. Okay, that will be the length of a segment that represents 1 over x. What's more, the actual length of this segment depends on the scale you choose for 1. How big is 1? Make 1 bigger than x, make it smaller than x. As much bigger as you want, as much smaller. Pick a convenient value for 1 and simply proceed. Now we're going to be able to use that to construct our graph of the cosecant function.